Hi, and welcome to the 10 square metre workshop. Regular viewers will know that I have a 3D printer, which I use for making various items around the workshop. But there are problems. The filament used is hygroscopic. It absorbs water. The filament comes in a sealed bag with a desiccant bag inside, and you can put it back in there. But so often it's sitting on the machine and you think, well, I'll be using it again tomorrow, I'll just leave it there. A couple of weeks later you come back and realise it's still there. Some people will build an airtight box above their printer, holding all their reels. The problem there is every time you open the box you let an awful lot of air in. The alternative is to use a cassette for each reel. This is not my idea, I got it from Ricky Impey. He has a very good site for matters 3D printing. Do check it out. The basis of the cassette is a hermetically sealed food container like this 7-litre version. Add in some 3D printed parts and you have the basis. The container is used vertically like this. And there's two major differences between Ricky's design and mine. Firstly, he has feet on the bottom so that it can stand on a shelf above the printer. Whereas I've produced this piece of 3D plywood origami that acts as the roof of my printing chamber. This means the printing cartridge will just slide in and lock in place. Secondly, whereas he uses calcium chloride pre-made modules that are discardable, I built this 3D printed container for silica gel. This can be regenerated by putting it in the microwave, so it's reusable. The first step is to position the spindle that the reel is going to rotate on. Instead of the plate of the original, which has through holes, I'm using a piece of aluminium plate which has been tapped 5mm. I want to keep the overall thickness of the module as slim as possible because they will be stacking next to each other. This allows the peg to be fitted on the other side, completing the reel. The filament feed hole is bolted to the bottom of the box with 3 4mm bolts, and the last step is to drill out the 2mm hole for the filament. The filament clamp is made from a 3mm bolt with a 3D printed head. Screwed together and with a lock nut fitted, it traps the filament whilst in storage to prevent it retracting. Last step is to hot glue mount the frame that holds the desiccant holder in place in the bottom of the box. I applied this quite liberally to make sure it stuck. The box is just a friction fit on the prongs and can hold quite a lot of desiccant. This, by the way, I bought in a 1 kilogram tub. It's supplied with colour change pellets, so you know when you need to regenerate it. And here is the cassette finished. Now I only need to make 4 or 5 more of them. In use, and get hold of the end of the filament, slacken off the securing screw, pull it out a reasonable amount, put the cassette on top, slide it in, retrieve the filament, feed it through the filament detector, and it's ready to go. This is my 3D printer chamber. It has doors at the side and the front, which latch shut to keep everything cosy. It has great access. I have a small 500 watt heater mounted to the wall of my chamber. It's not needed in summer, but really helps in winter. It's set to 30 degrees. On the back wall is a Wi-Fi camera, so I can keep an eye on print progress. And the cassettes will soon be replacing these reels. Since building the first one, I have redesigned the spindle so it only takes one bolt from each end. Much simpler, and it's all 3D printed. 4 more boxes have arrived, so I better get on with it. And yes, I will be fitting a hygrometer into each box. They're so cheap. Several prints later, in with a rack made from plywood, here are my 5 boxes. This will cover 97–98% of all my printing. I shall make a holder for ordinary reels for the colours I don't use very often. Well, that's all from the 10 square metre workshop this time. Hope to see you next time. Bye for now.